Hi everyone, my name is Haley Barrett, and today I will be presenting my project findings on the Great Barrier Reef. For this project, I wanted to learn more about coral reefs, as I did not know much about them prior, as well as to learn how they are being restored, how effective such tactics being used are, and to compare these global averages to what is being done within the Great Barrier Reef. This ecosystem is extremely important, as it provides a multitude of ecological services, in addition to containing 30% of all marine biodiversity. One key species is that of Scilactarian anthozoa, or hard coral, which is an animal, keystone species, ecosystem engineer, and reproduces both asexually and sexually, although the latter does not occur often. After growing into a polyp, releasing corallite, and rooting itself to an ideal substrate, zooxanthellae enter into their endodermis. These two species form a mutualistic relationship wherein the coral provides the photosynthetic algae protection, and it in turn contributes 90% of its energy to the coral. That being said, this relationship can be broken as a result of various stressors, which, if extreme enough, causes the corals to expel the algae, resulting in coral bleaching and potentially death. Important species that affect the coral's mortality as well is that of herbivorous fish and sea urchins, which help to remove the cyanobacteria and toxic algae from the water, lowering the chances of eutrophication, infection, or high turbidity from taking place. Contrastingly, predators such as the crown of thorns starfish, which is common in the Great Barrier Reef, consume corals excessively and unfortunately don't have many predators to consume them in turn. Other factors that can contribute to the health of this ecosystem includes natural threats such as the cyclone disturbance regime in the Great Barrier Reef, as well as anthropogenic threats such as pollution, which can contribute to eutrophication, poisoning, and suffocation of corals, and exacerbating other threats. The worst anthropogenic threat is that of climate change and ocean acidification. By burning fossil fuels, the Earth's temperature has increased greatly, and subsequently so has natural disasters, ocean temperatures, and acidity through ocean carbon sequestration. This has caused corals to have higher heat mortality, higher rates of disease, such as coral bleaching, and increased fragility due to lowered pH. This also serves to harm fish species, disrupting their ability to reproduce, swim, and for their larvae to survive. Reports show that by 2040, wide-scale bleaching will be an annual event, and by 2050, net reef dissolution will occur. Given these various threats, there are many efforts being made to restore coral reef ecosystems. Coral reef restoration is relatively new. Beginning in the 1970s, currently we are now in the third wave of reef restoration, and over that time we have developed three types of restoration practices. Artificial restoration, which is by using unintended structures, as well as intentionally made ones, such as biorock, which uses electrolysis to form limestone, a naturally occurring element in coral reefs, as well as at times cement structures such as rock balls or artwork. This practice serves to expand the area in which corals can grow and propagate colonies. Biological restoration is utilized to promote the quantity of corals within an already established reef that has experienced a reduction in its population and can involve collecting and rehabilitating naturally broken coral fragments, propagating coral colonies through coral gardens, which will be discussed more later in the presentation, culturing coral larvae, or transplanting living coral colonies. Ultimately, it seeks to promote a sexually reproductive reef through various outplanting efforts. Lastly, physical restoration focuses on the variables that influence corals' health, development, and reproduction, and institutes methods that have defined the third wave of restoration. One example is mineral accretion devices, which employs electrolysis to change the water's pH and improve the health of the corals. Another is algal enhancement, which involves thermally stressing, propagating, and then thermally stressing again, zooxanthellae to forcibly adapt the species to produce more heat-tolerant survivors so that they can be injected back into the coral. One study that I found that assessed the efficacy of a number of these methods was composed by Bostrom Enarsson and colleagues who, after assessing 362 studies from 56 countries, found that a majority employed coral gardening, and that rubble stabilization had the highest recorded survivability at 80%. Moreover, the average project covered a 100-meter square area, was monitored for 12 months, and had an average of 60 to 70% survivorship amongst coral. However, only 60% of the projects reported particular methods employed to assess growth and survivorship, and many were extremely inconsistent. Moving on to the study's main focus is that of the Great Barrier Reef, which is located in the Indian Ocean. It contains 3,000 reefs, 75% of which are bleached. In addition to this, it also provides 64,000 jobs and is designated as a World Heritage Site. Given its vast importance, this report, written by Diane Tart and Terry Hughes this year, assesses what the government is currently doing to restore the Great Barrier Reef after it took extensive damage during the 2016-2017 bleaching events. What was found is that the Australian government, while prioritizing restoration practices such as improving water quality through mitigating sediment and nutrient runoff, has not been funding those efforts enough to meet its 2025 goal. Even worse, the government was shown to also be actively destroying parts of the GBR for port development, as well as subsidizing fossil fuels, all of which is against stakeholder approval, clearly indicating that climate change and physical destruction will likely negate many of their current efforts if this trend continues. After determining what was taking place in the GBR overall, I then decided to examine a case study of one of the most popular coral reef restoration practices, coral gardening, and in this case, the first established multi-taxa in situ coral nursery. Conducted by David Sudgett and colleagues, the site of their work took place in Opal Reef, which, given its vicinity to 16 ports, was designated as having high-density tourism, which prompted the restoration's funding. Accordingly, due to a lack of historical references within the GBR, researchers assessed 52 relevant studies and established the return on effort criterion to assess the growth and survivability of corals, taking the percentage of each, due to a lack of universal standardized measurement for these two criteria. Two sites were then selected based off of the data that they found, and chose to incorporate 11 corals which ranged from R to K species type to promote diversity, as well as were selected for having survived the 2016-27 coral bleaching events. However, this was later determined to potentially be due to their location and heat refuges rather than their inherent adaptation to thermal stress. The first site, established in January, contained 11 coral taxa, and the second site, established later in August, incorporated only 6 of the 11 for repeat testing. Researchers selected specimens by hand, obtaining 5 to 100 propagules per colony, and measured them through scaled photographs. They were then placed on a small traversing tile and attached with cable ties to an aluminum mesh frame so it could be reused. Each outplanting was monitored for 1 to 2 months to assess survivorship. What researchers concluded was that more research is needed given the short length of monitoring and to confirm whether the coral will fare during the next major heat event. The overall growth and survivorship, or RRE score, has not improved globally over the 23-year span that their data was collected, and the taxa, while varying slightly based on their R and K designation, had very similar mean scores of RRE. That being said, a one-size-fits-all approach is not advised as more research is needed. Overall, this collection of works informed me that climate change, as a primary threat to coral reefs, must be addressed. Coral restoration efforts can be effective at propagating corals and should continue, and that funding, reporting, and standardization of survivorship and growth, such as RRE, must be established. That taxa should be more thoroughly considered, and that biodegradable materials should be used in restoration efforts as opposed to materials like concrete. These must all be considered in order to establish resilience within the Great Barrier Reef, as well as to assist restoration efforts within other reefs around the world.